The first circle theorem states that angles in a semicircle are equal to 90 degrees. This means that bringing the two ends of a diameter to any point on the circumference will make a right angle. Here you can see in both examples the green angle and red angle are both equal and they are both 90 degrees. If we instead look at a chord and bring the two ends up to the circumference, we do not make 90 degrees. Subtending a chord to any point on the circumference produces the same angle, provided that they are in the same segment. Two angles x are in the same segment, so they are equal. The two angles y are in a different segment, so they are equal, but not the same as x. Using the same angles as the previous example, we can illustrate the connection between angles x and y. They are now contained within a cyclic quadrilateral, that is a four-sided shape with all four corners on the circumference. Angles x and y are not equal, they both sum to 180 degrees. The theorem states that opposite angles in a cyclic quadrilateral sum to 180. Remember that all four angles will sum to 360. The next theorem states that the angle at the centre is twice the angle at the circumference. Angle x is subtended to the circumference from the green chord. Bringing the ends of the same chord to the centre of the circle produces an angle twice as big. The second example shows that the angle at the centre can be a reflex angle. The alternate segment theorem states that the angle between a chord and a tangent is equal to that angle which is subtended by the chord. X is made between the chord and the red tangent and is also produced at any point on the circumference by subtending the same chord. In this example, a different chord is used. The red and green angles are equal. In this example, you can see that the tangent meets a diameter. In this case, the angle will always be 90 degrees. Subtending the diameter to the circumference will always produce a right angle, as stated previously. A tangent by definition makes a right angle with a radius. Here, two tangents will meet at a point, resulting in two equal lengths. Together with the radii, the shape made is a kite with two right angles. Since the two right angles make up 180 degrees, the remaining pair of opposite angles also sums to 180. It may be useful to split a kite into two identical right-angled triangles, depending on the question. Remember to access circle theorem questions and any GCSE Maths questions via the KD Maths website. The first circle theorem to remember is that angles in a semicircle are equal to 90 degrees. What that means is if you draw a diameter right through the centre of a circle and you take the two ends of the diameter up to the circumference anywhere, the angle that is made at the circumference is always 90 degrees.